Hi, my name is Tejas Patel, and I'm a program manager in the Information Innovation Office at DARPA. Before I begin, I want to acknowledge that this is a pre-recorded talk. I'm not sure which is more painful, giving a pre-recorded talk or being in the audience for one. For that reason, I'm going to keep my remarks brief, and I truly wish I could be at the One Summit with you all in person. Unfortunately, it is a bit hard to be in 2 time zones at once. My portfolio at DARPA mostly centers around networking and cybersecurity. In that context, I run the 5G portfolio for DARPA. When DARPA set out to explore what the future of 5G looked like, we asked ourselves a simple question. How can DARPA have an outsized effect on the networking community? For us, the answer was quite simple. Focus on making security easy and readily available. The natural question was how to accomplish this goal. We did this by breaking the problem down into 3 parallel efforts across the RAN and core. The first is the Open Programmable Accelerators for 5G, or OPA 5G effort, focusing on the creation of a 5G reference waveform implementation. We'll talk a little bit more about this in 2 slides. The second is the Pronto effort, focusing on self-healing networks. This effort leverages commercially available P4 programmable switches to accomplish 2 things. First, it allows for the real-time line rate monitoring with in-network telemetry. Second, this telemetry allows for the deployment of formally verified corrective code into the network to correct aberrant behaviors. The third is the Open Programmable Secure 5G, or OPS 5G effort, focusing on adding security to core networks by recognizing that future networking equipment will be built upon commodity hardware. Over time, we expect these components to not just be extensions to 5G software, but baked into it from the get-go. The final question we ask ourselves in how to run these programs was what we should build upon. DARPA is in the business of running research projects lasting between 3 and 4 years, not in long-term sustainment. This meant that greenfield development was out of the question. Instead, we turned to the Linux Foundation to build upon the 5G Super Blueprint, leverage their existing relationships with the open source community, and utilize the Linux Foundation's proven track record for enabling long-term sustainment and evolution of open source projects. I want to highlight just a few touch points we have with the 5G Super Blueprint. There is Peraton Labs focusing on remote attestation of user equipment and distributed denial of service mitigation of core infrastructure. USCISI is focusing on secure network slicing in the core. Pronto is focusing on closed-loop control that spans all the way from the user edge to the core network. And finally, we have software radio systems creating an open-source 5G waveform. Now, by itself, open-source software is not useful. The value comes from how the source code is developed. To that end, we have SRS focusing on developing functionalized software versions of 5G handsets and base stations, with an emphasis on ease of readability, flexibility, and modularity. This allows anyone to audit the code base and have confidence in the software stack. This is particularly important given the growth of tunable network parameters as we have moved from 2G, 3G, all the way to 5G. Having an open source implementation allows anyone to tune these parameters and see exactly what effect this tuning has. No longer are we in the world of black box testing. This is particularly important to the DoD, as we will often find ourselves not just in unknown environments, but potentially hostile environments, and being prepared for hostility is often the difference between life and death for our deployed service members. Now, the final thing I want to discuss is not 5G specific, but a more generic effort that we are about to undertake at DARPA called CASTLE. We're taking a look at automating network security by treating it as a reinforcement learning problem. Now, when it comes to reinforcement learning, there are really 4 fundamental things that you need to keep in mind. First, you need an environment. Second, you need agents. Third, you need a set of actions these agents can take. And fourth, you need to know the rewards that these agents can earn for taking the right actions. Keeping that in mind, the question is, how does this apply to network security? For CASTLE, the idea is to take any network, realize that it is vulnerable, whether we know it or not, and automate the scanning of this network and creation of a simulation environment, or an AI gym. Within this AI gym, we have two agents that will repeatedly play a game. The first is a blue or defensive agent that will take actions to protect network services such as email. The environment gives rewards for keeping these services up and running. The second is the red or offensive agent that will take actions grounded in real-world tooling that we can expect malicious actors to use. The environment gives rewards for reducing the availability of these network services. Once we refine blue and red agents in the simulation environment, we can automate the instantiation of instrumented subnets or high-fidelity emulation environments specifically to test out the validity of our agents. This serves two purposes. First, it gives us confidence in our agents, and when we are confident, we can transfer them to our vulnerable networks and harden them. Second, it provides us the feedback necessary to have confidence in our simulation environment. And when we lose confidence in the simulation environment, it provides us the roadmap as to how we can further improve our simulation environment. For more information on CASTLE, I encourage you to visit DARPA's Opportunities page. And with that, thank you for listening to my talk, and I look forward to seeing you all in person next year.